Hey guys, it's Mr. Gibson. I'm going to take you guys through some similarity proofs and how we do some of these things. Real quick right here. First, I'm going to take you through some common angle equalities that we deal with. First is the vertical angles theorem. It says this: so ACB, this angle, is equal to DCE. Okay, and because they're across the vertex from each other. That also means that, I didn't write this down, ACD is equal to BCE. Okay. Alright, so that's the vertical angles theorem, so think across the vertex. The next set of angle equalities that we have here are when you have two parallel lines cut by this line right here that we call a transversal. So if we look at 1 and 5, if you see 5 and 1 here, it looks like you take 5 and you could slide it on top of 1. So they're equal. They're called corresponding angles. Look at 3 and 7. Looks like you could slide them on top of each other. Corresponding angles. 4 and 8, same way. 6 and 2, same way. That's corresponding angles. You can think of them like a translation. You could slide them on top of each other. Next, we have alternate interior angles. So, a few words here. Alternate, to me, means you're going across the transversal. You're not saying on the same side of the transversal. You're going across it. Interior means you're on the inside of these two parallel lines. So, if I look 3 and 6, okay? 3 and 6 across the transversal inside of the parallel lines, alternate interior angles. Same with 5 and 4, okay? Alternate again across the transversal, but now exterior angles, okay? So on the outside of these parallel lines. So 7 and 2 across the transversal, outside the parallel lines, alternate exterior angles. Same with 8 and 1, okay? You can also tell here that 1 and 4, 3 and 2, 5 and 8, 7 and 6, all vertical angles as well. Now the final idea here is if you have the same angle on top of itself, it's called the reflexive property. Okay? So if you look here, BAAC is right on top of DAC. Okay? So you'd say BAC and DAC are equal by the reflexive property. Okay? So we're going to use these properties in our proofs for similarity. Now, the big question now is, how do you prove triangle similarity? Okay? First, I want to get the idea pounded in your head here that similar means same shape, different size. Okay? So first thing is AA similarity. This means two triangles have two equal angles. So these two triangles have corresponding angles that are equal. Well, if two angles are equal, all three angles are equal. If all three angles are equal, it's pretty much the same shape. Okay? Might be a different size. So these two triangles would be similar. The next similarity is SAS similarity, side, angle, side. Okay? But what these two sides mean is that the two corresponding sides are the same proportion. Okay? So when I take new over old or old over new of each of the corresponding sides, I'll get the same proportion. And in between both of those, the corresponding angle is equal. So here's a little example right here. I have a corresponding side 5 that corresponds to 10, this side 10. And I have a corresponding side here 6 to 12. 5 over 10 is equal to 6 over 12 because they're both 1/2. If you look between both of them, those corresponding sides, you have an equal angle. This would be side, angle, side similarity. Now the final similarity is SSS similarity. Again, it doesn't mean all three sides are equal. It means all three corresponding sides have the same proportion. Okay? So if I look here, I have 1 is corresponding to 4 here. So 4 over 1 is the same as 3 corresponding to 12, so 12 over 3, and 16 corresponding to 4. Well, all three of those are equal because they all equal 4. Okay, so those are some postulates and theorems that we're going to use when we are proving triangle similarity. Now let's look at a few examples here. Okay, Showing you guys a few drop down examples because we think that's what you'd see on your test. All right, so if I look at these two figures, QRU and QTS, okay, QRU, okay, these two triangles right here. It's given that these two lines are parallel. It says that this angle and this angle, okay, SQT and RQU, they're equal to each other. They say it's vertical angles there and perfect. You got these alternate angle U is equal to angle S, again across the transversal inside the parallel lines, alternate interior angles. Well, if you look, that means that I've got this angle equal to this angle equal to this angle. I've got two angles that are the same. That means I'm going to have AA similarity. So let's choose that. Okay. If I choose that, hit submit. Great job, we got that one, okay? Let's see one more from this, okay? All right, so given, it says these two angles are equal. These two angles right here are equal. And then it says S is equal to S. By that reflexive property of congruence, okay? Well, again, guys, two angles on two triangles are equal, so it means that this triangle and this triangle, okay, SUW and SVT, they're going to be similar to each other, again, by AA similarity, okay? Enter. All right. Let's check that one. And since those were pretty similar, let me do one more with us. All right, again, another AA similarity. That's what we're looking for here. So we need to show that a few more angles are equal. So we have VYZ and XWZ. Okay, these two triangles right here. We're given that you have two parallel lines. We're given that Z is equal to Z. Okay, that's the reflexive property. It's just on top of itself. All right, now it wants us to it's telling us why does YVZ equal to angle X. So these two angles right here, well, those are the two that I would slide on top of each other. So I know that those are corresponding angles. So I'll hit this corresponding angles postulate, press enter. Brilliant. Brilliant, okay? All right, so most of these are, I'm going to go back and go into another set of proofs here. See if they can give me a few more examples here that are a little more difficult. Okay, again, this is showing similarity. It's showing that two sides are going to be proportional. But if I look, it's saying Y is equal to U, W is equal to V. Well, these two triangles are similar by, again, AA similarity. Kind of seeing a common theme here that's asked a lot, isn't it? All right, let's do probably one or two more. All right, so given that these two angles are equal, oh look, it's saying VY over WX is proportional, is the same proportional as TY over UX, okay? So we got proportional angles, or proportional sides, with an angle in between them that's equal, okay, SAS similarity. So it's saying, okay, well, Y is TVY equal to UWX. Well, the corresponding angles are going to be the same in a similar triangles. So if I'm looking through that, you might see something that says corresponding angles are equal in similarity, or I might even just use this right here, definition of similarity, right? Definition of similarity is same shape, different size. So that means they have the same shape. It's got to have the same angle. One more here, because I'm probably boring y'all to tears. Given that these two are equal, oh look, it's just saying this and this are these two angles right here equal because of vertical angle theorem. Well, again, we got AA similarity. Okay. There we go. And oh, well, you know what? This is a more difficult one. So you know what? Let me go through it real quick. Okay. We have VX and UX have the same proportion as XT and YT, okay, or yeah, WX, sorry, right there, okay. So we got proportional sides. Oh look, X is equal to X, that's reflexive, because they're the same. Okay, oops, go back. Now, we have two proportional sides, an equal angle between them. Well, that means you're going to have SAS similarity. And then finally, well, we've got TVX and WUX are equal to each other. Well, they're going to be equal to each other because if the two triangles are equal to each other, well, their corresponding parts better be equal. Let's see. Let's do definition of similarity. There you go. Just press enter. Wonderful. Did a good job. Thanks for listening, you guys. Good luck on your EOC.